In this video, we'll give a brief overview of the micronutrients. By micronutrients, I of course mean the vitamins and minerals. Both vitamins and minerals are substances that we must get in our diet. They're mostly not made by our body. Vitamin D is one exception to this. It is actually made in our body, and we get it from our diet. Vitamins and minerals are called micronutrients because they're required only in small amounts. For the macronutrients, the carbohydrates, proteins, and lipids, the recommended intake is in grams. For the micronutrients, the recommended intake is measured in milligrams, which are 1/1000th of a gram, or even in micrograms, which is 1/1,000,000th of a gram. Now, this is just a short introduction. I'm not going to go into details about specific vitamins and minerals. These will come out in your reading. First, a little bit about the vitamins. Remember that the vitamins are organic molecules, and also remember that by organic, I mean the chemical definition, which means that they contain carbon. So the vitamins are carbon-containing molecules. Vitamins are not broken down for energy, so vitamins do not contain calories. And there are two categories of vitamins. There are the water-soluble vitamins and the fat-soluble vitamins. The water-soluble vitamins are the B vitamins and vitamin C. When you refer to the B vitamins, you always use the plural because there are actually 8 B vitamins. Thiamine, riboflavin, niacin, biotin, pantothenic acid, folate, vitamin B6, and vitamin B12. They all fall into this category of B vitamins. The fat-soluble vitamins are vitamins A, D, E, and K. Water-soluble vitamins can dissolve in watery solutions, like your digestive juices or your blood. So when you eat water-soluble vitamins, they're absorbed straight into the blood. Fat-soluble vitamins don't mix well with water. Fat-soluble vitamins are absorbed along with fats in the diet. So if you eliminated all fat from your diet, you'd end up deficient in the fat-soluble vitamins. These vitamins are absorbed into the lacteals and lipid droplets, and they require transport proteins to be circulated in the blood, because remember, blood is a watery solution. The solubility of different vitamins affects the absorption and transport of these vitamins, and it also affects how these vitamins are stored in the body. Water-soluble vitamins circulate in the watery solutions of the body. Fat-soluble vitamins are stored in fatty parts of the body. These differences in storage affect a number of other aspects of the vitamins, including excretion. If you take in more water-soluble vitamins than your body needs, they're easily excreted in your urine. So if you take a megadose of vitamin C, for example, more than your body can use, all you're really doing is making very expensive urine. Fat-soluble vitamins stick around. They don't dissolve in blood or urine, so they aren't easily excreted. This means that if you take high doses of vitamins and supplements, the fat-soluble vitamins may just accumulate and accumulate until you actually reach toxic levels. Also, since the fat-soluble vitamins are stored, you don't necessarily need to take them as frequently. With water-soluble vitamins, you need a regular, steady intake every day or every couple of days. But with fat-soluble vitamins, you can build up a store and then go without for a while. Now, the minerals are inorganic micronutrients, meaning that there's no carbon. They also do not provide energy. They cannot be broken down for energy. The minerals fall into two categories, the major minerals and the trace minerals. The major minerals are needed in relatively larger amounts, so over 100 milligrams per day. The trace minerals are needed in smaller amounts, trace amounts. So for these guys, you need less than 100 milligrams per day. Now, just because you need these minerals in small quantities, they're trace minerals, doesn't mean that these minerals are unimportant. I mean, if you look at some of the minerals on here, you've got iron, We've got iodine. If you don't get enough iron, you get anemia and you start feeling tired and weak. If you don't get enough iodine, your thyroid gland can't function and you may start experiencing hypothyroidism and maybe even develop a goiter, a visible swelling of the thyroid gland in the neck. One important topic to consider when you're discussing the micronutrients is bioavailability. Bioavailability refers to the amount of a nutrient that can be absorbed and actually used by the body. So it's important to understand that we don't get 100% of the nutrients that we eat. We don't. There are always some nutrients excreted that our body just doesn't take in. How much of the nutrients we eat we can actually use depends on how much is in the food. That is an important factor, but it also depends on how much we can absorb at any given time. And there are specific factors that affect absorption from vitamin to vitamin. So different vitamins and minerals are affected by different things. Storage and preparation is one factor that affects bioavailability. This affects the amount of nutrients that are actually in a food at the time we put it in our mouths. And we'll talk a little bit more about how to minimize nutrient loss at the end of this video. For now, think back to the fact that that all vitamins are organic and that minerals are inorganic. That, as well as the solubility of the vitamins, can affect the bioavailability in food. Since vitamins are organic, they can be broken down over time. Some are vulnerable to light exposure, some are vulnerable to heat, some oxygen will break them down. Vitamin C is vulnerable to light, heat, and oxygen, so vitamin C is a very vulnerable vitamin. Water is an important factor in preparation. Minerals and water-soluble vitamins will leach out into water if you cook vegetables over a long period of time. And some vitamins may also break down in prolonged heat, so heat is another factor. Now, all of these other factors affect the absorption of the micronutrients. Remember in week 2 we discussed primary and secondary nutrient deficiency. So remember, primary nutrient deficiency occurs when you just don't eat enough of a particular nutrient, but you can also have a secondary nutrient deficiency where you're eating the nutrient but you can't absorb it for some reason. So absorption is an important thing to consider when thinking about the bioavailability of nutrients. One factor that affects absorption is the time food spends in the GI tract. If food spends less time in your GI tract, you have less time to absorb the nutrients out of that food. So if you have, say, chronic diarrhea, you're not going to be able to get many nutrients out of your food. Other foods eaten at the same time can affect absorption. For example, if you eat a very low-fat diet, you're going to not be able to absorb as many fat-soluble vitamins, particularly vitamins A and E. You might become deficient if you tried to eliminate all fats from your diet. Another example of this is that vitamin C increases iron absorption. So if you find yourself iron deficient, you might want to consider having an orange or some other food that's high in vitamin C with your source of iron. For some nutrients, the source of that nutrient can affect its absorption. Iron is the best example of this. Iron from animal products is in a molecular form that's actually better absorbed, so it's easier for us to get iron out of animal products than out of plant sources. Plant sources also have other molecules called phytates, and they're found in legumes, whole grains, and in rice that actually inhibit the absorption of iron. Also, high levels of calcium and tannins that you find in tea, coffee, and red wine can limit the absorption of iron that you get from plant sources. So, if you are vegetarian or vegan, you may need to have a higher iron intake because all of your iron is coming in a form that is not as well absorbed. The health of the GI tract can affect absorption. For example, if you have celiac disease and you don't have as many villi, You can't absorb nutrients as efficiently. Another example is atrophic gastritis, stomach inflammation in the elderly. The stomach stops producing intrinsic factor and the body can't absorb vitamin B12. So your digestive health can be a major contributor to absorption. Lastly, your previous nutrition status or your previous nutrient intake can also affect the bioavailability of the foods you eat. Vitamin D is a great example of this. Vitamin D is essential for calcium absorption. So if you're vitamin D deficient, you're going to be calcium deficient as well. Some vitamins are found in food as precursors. These are actually sometimes also called provitamins. These precursors, or provitamins, are converted to active vitamins once they're in the body. Beta-carotene is a good example of this. Beta-carotene is a vitamin precursor that's found in red-orange fruits and veggies. And it's converted to retinal, which is a form of vitamin A, once it's in the body. Tryptophan is another example. Tryptophan is an amino acid, so it's actually found in protein-rich foods, and that's a precursor to the vitamin niacin. So tryptophan can be converted to niacin once it gets into the body. One other important thing to consider when you're discussing the micronutrients is that more is not necessarily better. Remember the tolerable upper intake levels, the ULs? Many micronutrients have toxicity at high levels. Take vitamin C, for example. If you take super high levels of vitamin C, it can damage your cells. It can interfere with certain medications, particularly anti-clotting medications. It can also interfere with diabetes tests at high levels. Now, vitamin C is a water-soluble vitamin, so you pee out the excess. So it does take very high levels to see toxicity. But it is possible, and if you see someone taking lots of vitamin C supplements, it can happen. You also see toxicity with excess calcium. It can cause the development of kidney stones. Excess sodium can lead to high blood pressure, at least in some people. So with the micronutrients, remember that more is not necessarily always better. More might be good up to a point, but if you go past that point, it starts getting bad for you. Now think back to our discussion of the dietary reference intakes. The dietary reference intakes include the recommended dietary allowances and the adequate intakes, the RDAs and the AIs, that tell you how much of a nutrient you should be getting in your diet. This is an example of the DRI chart for vitamins. The DRI charts are freely published, readily available. If you go to this website, you can find a whole set of DRI charts for vitamins, for minerals, ULs, as well as the RDAs and AIs, and you can even find the EARs. One thing I want to point out about these reference intakes is that they are separated by age and they're separated by gender. So you have the females here and then the males there. There are also separate recommendations for women who are pregnant or who are lactating. Now, the reason why these separations are there is because these are all factors that can affect an individual's nutrient needs. For example, let's look at vitamin C. Females on average need less vitamin C per day than males, and part of that is because females on average have a smaller body size than males. But if a female is pregnant, their vitamin C requirement goes up a bit. If you're between 19 and 30, it's 75 milligrams a day, 85 milligrams a day if you're pregnant. And if you're lactating, your vitamin C recommendation goes up dramatically to 120 milligrams per day. Remember the difference between RDA and AI. The AI adequate intake means that there's insufficient data to really calculate a solid RDA, but it can still be used as a target for daily intake. This page summarizes some of the general roles that vitamins can play in the body. Remember, your reading will discuss roles of specific vitamins. Now, one major role of vitamins is to serve as coenzymes for various important reactions in your cells. Remember, coenzymes are organic molecules that are necessary for enzymes to do their job, like organic enzyme helpers. This image shows you the coenzyme NAD+. It's an important coenzyme in cellular respiration. It's one of the high-energy electron carriers that gets the electron transport chain started. Niacin is one of the B vitamins. It's also known as vitamin B3. Niacin is this piece over here in blue. It forms part of the NAD+ coenzyme. So the vitamins themselves aren't coenzymes, but the vitamins form an essential part of coenzymes. So many of the B vitamins, like niacin, form coenzymes important for cellular respiration, for making ATP. There are other vitamins that form coenzymes important to making essential molecules, like neurotransmitters, hormones, non-essential amino acids, lipids. The B vitamin pantothenic acid is a good example of this. It's used to make acetyl-CoA, which has a role in cellular respiration, but is also used to make neurotransmitters and the hormones estrogen and testosterone, among other molecules. Some vitamins form coenzymes involved in DNA synthesis. Anytime you're making new tissue, you need to make new cells. This happens when you're growing, or when you need to heal a wound, or just during normal turnover of your digestive tract or your blood cells. In order to make new cells, you need to make new copies of your DNA. Vitamin B12 and folate, otherwise known as vitamin B9, are particularly important in DNA synthesis. Some vitamins help protect your cells against free radicals. Free radicals are highly reactive molecules that can damage the lipids, proteins, and DNA in your cells. Antioxidants like vitamin C and vitamin E help mop up the free radicals and minimize the damage these molecules can do. Hormones are small molecules that regulate processes in the body, and there are a few vitamins that can act as hormone. There's actually a form of vitamin A called retinoic acid that is critical in regulating growth and development. This page summarizes some of the general roles of minerals in the body. Several minerals, particularly sodium and potassium, help to keep a stable distribution of water in the body. By distribution of water, I mainly mean the distribution between the fluid inside your cells and the fluid outside your cells. Fluid balance also involves the balance between water taken in and water excreted. Sodium and potassium help regulate your urine output as well to keep you well hydrated. Some minerals act as structural compounds, like the calcium and phosphorus in your bones. That's kind of a macroscopic scale, a large scale. But on a smaller scale, there are minerals that are part of essential molecules, like phosphorus in making ATP, or iodine forming part of thyroid hormone. Several minerals act as cofactors. Remember, cofactors are inorganic molecules that activate enzymes. They usually work along with coenzymes. Zinc, magnesium, iron, copper are all important cofactors. And there are also minerals that act as ions in the nervous system and in signaling between the nervous system and your muscles. Sodium, potassium, and calcium are particularly vital for nervous system and muscle function. As my last topic in this video, I want to talk a little bit about how to minimize nutrient loss. Now, there are three main routes to nutrient loss. First is breakdown by enzymes within the fruits or vegetables. Second is loss to water during cooking. And the third is chemical change due to interaction with oxygen. Oxygen likes to react with molecules in your food, and it can cause breakdown, particularly of the vitamins, of some vitamins. Now, I want to discuss this because it's a concern that a lot of people have, but I do want to point out that in most cases, nutrient loss is really quite small, and it's not worth spending hours of your time fretting about what the absolute best way to keep all of the nutrients in your food is. If you're eating a lot of fruits and vegetables, you're going to be fine, even if those fruits and vegetables are all cooked. But when we are thinking about nutrient loss, there are two avenues that we need to think about. The first is storage, what's happening to the nutrients in our food as we're storing the food. The second is preparation, what's happening to the nutrients as we cook them. For storing foods, refrigeration can sometimes help preserve nutrients. It slows down degradation, so it slows that enzymatic breakdown of vitamins that can occur. It also helps to store cut fruits and vegetables in airtight containers. So if fruits and vegetables are uncut, they're a little bit more protected, but once they're cut, there's more surface area that could be exposed to oxygen. If you put them in airtight containers, they're going to be exposed to less oxygen. Freezing significantly slows degradation, particularly if it's a quick freeze, a flash freeze, that can significantly preserve nutrients in food. As far as cooking, it's best to cook food fast, cook it in minimal amounts of water, and if possible, if you are cooking food in water, incorporate the water into the food by eating it as a stew or a soup. If you incorporate the cooking water into your food, you can still consume the nutrients that have leached out into the water. Now, it may surprise you to learn that microwaving actually preserves many nutrients. Microwaving is fast, and it can be done with minimal amounts of water. There is an exception, though. Vitamin B12 is actually destroyed by microwaving. You see about a 30 to 40% loss of vitamin B12 when you microwave your food. So I can't recommend that you microwave all your food. This chart gives you a quick overview of nutrient loss through various methods of storage and preparation. It gives you an idea of what happens with various methods, although the actual numbers are very variable. Note that freezing really conserves the majority of the vitamins and minerals. For everything except vitamin C, we're only seeing 5% loss, some 0%, and 10% loss, a couple of 10% losses. So freezing really conserves a lot of the vitamins and minerals. If you look at drying, on the other hand, drying, you see a lot of nutrient loss. So vitamin A is half gone. Vitamin C, you're losing out on 80% of the vitamin C. Half of a lot of the B vitamins. It doesn't really affect the minerals so much, but it does have a significant impact on the vitamins. With cooking, you're looking at cooking and then consuming the water, cooking and then draining the cooking water away, and then reheating, which is the microwaving. With cooking, you lose a substantial amount, particularly if you drain the water away afterwards. As much as 75% of your vitamin C, 70% of your thiamine, 75% of some of the other B vitamins. Generally, if you look at reheating, microwaving here, the losses are usually much less. 10% along here, 30 to 45%, and no mineral loss. One of the things that's interesting to note is that if you look at vitamin C, remember I said vitamin C is very vulnerable? It's actually lost really easily. Vitamin C is water soluble, it is vulnerable to oxygen, and it's vulnerable to heat. So almost anything you do to a fruit or vegetable will lose vitamin C. 30% loss, 80% loss, 50%, 75%, 50% loss, even in the microwave. So this is a significant argument for getting fresh fruits and vegetables in your diet to make sure you're getting an adequate amount of vitamin C. That quick overview chart is actually based on extensive research carried out by the USDA. The actual data, the more specific, more exact numbers from the USDA are freely available on the web at this address. If you go to this website and look at the document from 2007, You can look at various types of food. You can look up various types of food prepared in various ways. So like here we have lamb broiled, here we have ground lamb broiled, roasted, browned and simmered, reheated, liver fried or reheated. And then once you find the food that you're interested in, you can see the percentage of various nutrients retained with different cooking methods. Now this is actually showing you the percent of nutrients retained. So 100% retention of calcium when you microwave legumes. That means that you're saving all of the calcium. So if you really want to take your favorite food and figure out what's the absolute best way to prepare it to minimize nutrient loss, this is the place you want to go to get the actual numbers. Ultimately, though, there's one thing that I want you to remember, and that's that the only nutrients that count are the nutrients you actually eat. So, for example, say you hate raw carrots. The thought of them just makes you queasy, but you really love stewed carrots. They're your absolute favorite. I don't want any of you to sit there and think, man, I guess I have to eat raw carrots. I just won't get any nutrients if I cook them. As I said, the nutrient loss with cooking is pretty minimal, and you'll get a lot more valuable nutrients if you sit down and eat a hearty plateful of stewed carrots than if you manage to barely, grudgingly choke down a couple of raw baby carrots. In other words, the best way to prepare veggies and fruits is the way you'll actually eat them. We've covered a lot of ground in this video, and I hope this gives you a bit of a background to help you as you get into the reading in your textbook. Use these recap questions to quiz yourself on the important concepts, the important ideas in this video. If there's anything that you cannot recall, make sure you go back and study that section.